Previously on MindFlareRetro. MFR shows his face after a long time away and apologizes for not posting a video in over 6 months.
Oh, scheiße. So be sure to... Oh, I can't even effing read this. Oh, God, it's so fast.
After getting his act together and eager to get things rolling again, MFR wanted to show how to build a BWAC C64 Saver version 2.4 from scratch. BWAC had created this saver design free for all to use, and MindFlareRetro teamed up with PCB to sponsor his new video and manufacture the printed circuit boards for the C64 Saver. But first, MFR blathered on why Commodore 64 power supplies fail and what some of the options are to protect our precious C64s. After the lesson, that included some cutesy low-budget animations, MFR shows everyone how to acquire BWAC's design files, how to order the PCBs from PCB, and how to order the required components. Now, in part 2, MindFlareRetro will finally build BWAC's C64 Saver version 2.4. Will everything go okay? Will he succeed? And what's with the potato? Stay tuned to find out.
Hello everyone and welcome to part 2 of our C64 Saver version 2.4 Build It From Scratch project. If you happen to miss part 1, I highly recommend that you watch that first. You will find a link to part 1 in the description, or you can click on the link at the top of the screen. To quickly recap, in part 1 of this video series we did 3 things. First, we acquired BWAC's printed circuit board design files for the C64 Saver. Second, we submitted these design files, or Gerber files, to PCB to manufacture our printed circuit boards. And the third step was to organize a list of all the electronic components that we would need to build a C64 Saver, and we ordered all of those parts. Now, in part 2, we will assemble all the components and hopefully complete the construction of our C64 Saver. To begin this soldering adventure, I decided to start with the only SMD or surface mount device on the board, this little MOSFET. This device package is called a deepak or a TO252. Admittedly, I have never soldered one of these devices before. The little gate and source legs at the bottom seem pretty straightforward. However, the drain connection has quite a large surface area covering most of the underside of the little package that I assume acts like a heat sink and will require a little extra solder to be flowed underneath. I've been handling these little printed circuit boards with my grubby hands quite a bit, so I think I'm going to use some IPA and clean the surface of it before I begin soldering. Is this absolutely necessary? No. Is it good practice? Yes. Easy peasy. I'm going to prepare the pads with a no-clean flux from this syringe, and tin the one pad with a little bit of solder, and then use my soldering iron to tack down one leg. That one pad is tinned nicely, but as I think about this some more, once I tack down that one leg, I'm not going to be able to apply flux to the other pads, so I think I'll apply the flux now. You could solder this without the flux, but I think using the extra flux allows for a much better connection, and the iron dwell time is reduced significantly. And it doesn't take much time at all to secure that leg. That looks good. Now let's take care of the second leg. Now, just to make sure that the component is flush to the surface of the printed circuit board, I'm going to hold it down with some tweezers and quickly reflow the two legs to make sure that it's all flat. Looking good so far, but now I have to deal with that larger drain connection. The large drain connection has an exposed tab across the top. I'm going to add a little bit more flux to that, and then I will flow solder across there, and hopefully it'll travel underneath. Perhaps I should have tinned the pad first? I'm not quite sure, so you can leave your comments and criticisms below. Now, if I screw this up, it's all because I'm preoccupied by that gnarly hair on the bench. Solder, solder, solder. Flow, flow, flow. Ooh, shiny. On the whole, the soldering iron approach worked pretty well, although I do have a little bit of solder that taffied off the end there. Taffied. Is that a word? Oh, wow. No, that's not good. That's far too much solder. How did that happen? That has to be fixed. Time for some solder wick action. After spending a bit more time wicking off that extra solder, I think I'm going to give the board a clean and inspect my connections a little bit better. I'm using a dedicated flux cleaner spray here. Normally I would use IPA, which is perfectly fine, but this stuff seems to work a little bit faster and gets the board a little bit cleaner. All cleaned up, and that looks much better. Of course, using a soldering iron is not the only way to solder on this type of component, so I want to try soldering on another one using solder paste and hot air. However, although I've kept these refrigerated, which helps prolong the life, they are both very well expired. And to my understanding, that means that the flux has hardened up and it'll be difficult to dispense, and the flux won't do its fluxy thing. However, being the creative tinkerers that we are, I happened to watch a great video by SDG Electronics a couple of months ago. A great channel, by the way. And he was in the same kind of predicament, having to use expired solder paste. And what he did was to mix in some fresh flux paste into the dried up solder paste, and that seemed to solve the problem. It worked really well for him, so I'm going to try that here. I've dispensed some Mechanic brand leaded solder paste on the left and comparable Chip Quick solder paste on the right. I'm adding a little bit of MG Chemicals No Clean Flux paste to both. I will mix it in and hopefully reduce the viscosity of this now thickened up expired paste, and hopefully improve the performance of it as well. That is a much better consistency. Now let's try it out. I have here a fresh PCB and my rejuvenated solder paste. I'm going to be using the Mechanic brand one and apply it manually to the 3 pads. Of course, in a perfect situation, I would have thought ahead and had a stencil made so that I could apply solder paste perfectly to these pads, but in our case, I don't have a stencil, and I'm going to apply it manually. Applying solder paste manually is always a little bit tricky because you don't want to apply too much. Otherwise, when you use your hot air, you'll end up with extra solder that balls up and squeezes out from under the pads. If I had been using a stencil here, I would have a perfectly smooth and even coat of solder paste across this larger pad, And in our case here, I do not have that. Well, that's as good as it's going to get for now. I say we give this a shot and see how it goes. Now all we need to do is place this deepak component on the pads, as close to the pads as possible. We don't need to be overly accurate with the placement of this component, because once we start using hot air and the solder paste becomes molten, surface tension will pull the component legs even with the pads. I'll be using my cheapo Chinese hot air rework station that I actually showed in a previous video because it had all kinds of issues when I got it. Check out that video if you haven't seen that. I have the temperature set to 375 degrees Celsius. The airflow is set to 5 out of 8, which is the maximum. And I'm using an 8mm round nozzle. I'm starting with the hot air nozzle about 8 or 9 centimeters, just over 3 inches above the surface of the printed circuit board. And I'm using a circular motion trying to heat up the entire board itself. This is a very small printed circuit board, so it's pretty easy to do. What you don't want to do is concentrate the heat on one particular area of the board, because that can cause some very serious damage, such as warping or lifting of the layers of the board. If all is going well, you will actually start to see the flux in the solder paste start to activate. The solder paste takes on a very liquidy appearance, and then before long it will go molten and start to flow. And as it does, I move the nozzle in a little bit closer so that the molten solder soaks well and makes a really good connection between the component and the pad. Such a cool thing to watch. And that's it. I think we did a pretty good job. And let's take a closer look at our hot air handiwork. At first glance, those leg connections look pretty good, but I'm not entirely convinced that they're actually touching the surface of the board. They perhaps could be down further. Oh, and we have a solder blob. That is from having too much solder paste, and it's squished out from underneath. That can be wicked up with some solder wick. And finally, the large drain connection looks pretty good, but I think I'd like to add more solder to it. I just feel better that it has that shiny solder on top. So I'm going to add a little bit of flux. And I think I'll try to push those legs down a bit with a hot soldering iron as well, so they get a bit of flux as well. As does the solder blob, which we will wick up now. Bye-bye blob. And adding a bit more solder to the top of this tab. Again, I don't know if this is absolutely necessary, but it sure does look like a better connection. And finally, I'm going to reflow these legs and try to get them pressed down a little further. Man, I should just learn to leave well enough alone. Now I think it's too much solder on the legs, and I've accidentally dragged some solder filling one of the resistor through holes. So that will have to be cleaned up too. Okay, I've tidied up those leg connections now, and I'm quite happy with how they are at the moment. I still do have to deal with the covered up resistor through hole, but I'll deal with that shortly. And I think at this point we're good to move on to installing other components. Now that the only SMD component is finally installed, we have to look at a couple of little things. We need to add some jumpers. Well, the C64 Saver version 2.4 has been designed to accommodate an add-on board that adds a voltage and current display. We will look at that add-on board in a future video, but for now, seeing as we're not using an add-on board, we need to complete the connection between these 2 points of what would normally be a pin header for attaching the physical add-on board. To make these little jumpers, I have saved some cutoffs from resistors and capacitors that I will form into little jumpers and then solder them into place. I've made 2 of the little jumpers here, and I will make another one, show you how I do it. I have this small pair of needle nose pliers that makes it really easy just to bend these into shape. And if I put the tip of the pliers right about here and bend the other side, I conveniently have the perfect width to fit between the 2 through holes. I can then snip off the long side like so, and then I have my little jumper. I've made another one for good measure, and now they can be inserted into the through holes that they need to jump, and I will solder them from the other side. And now we just need to solder them like we would any other component, and we have our jumpers in place. And now we just snip off the excess, and we're good to move on to the next components. Jumpers are now in place, although in the future I think I will use a slightly tidier method. But moving on, we can now install all of these resistors. I confirmed all the resistor values and then took the time to label the resistors that I'm going to need, just to make assembly a little bit easier and less confusing for me. I have 2 of the resistors soldered in place here, and I'll just add the 3rd one. Not that you need to see this, but if you're like me, I could watch people solder components all day long. Oh heck, let's watch one more for good fun. I should mention as I fumble around with this that these are 1/8 watt resistors. They're quite small and a little bit fiddly to handle. And of course, if you haven't seen it before, blue tack is your friend when holding things down while you solder them. This row of resistors is soldered in place, and we can snip off those legs. Very good. And time for a tea break. Oh, hey everyone. Just stopping for a quick cup of tea and a Commodore cookie. Yep, a Commodore cookie. Well, not so much a Commodore cookie, but a cookie in the shape of the Commodore logo. I met a gentleman named Josh at the World of Commodore show that was here back in December. Josh was selling some interesting cookie cutters that he designed and 3D printed using food-grade PLA. I bought myself a Commodore cookie cutter, and Josh generously offered to donate one to the channel here to be used as a giveaway gift. So, if this is something you're interested in and interested in participating in winning this giveaway, you must be a subscriber to this channel, you must leave a comment below, and include the hashtag Commodore Cookie. Spelling counts. Also, please visit Josh's website, www.signalsfromspace.ca, and check out all the different designs he offers. And shipping to Canadian residents is free. Oh yeah. This is also a good time to let you know that this video is sponsored by PCB Way. PCB Way. PCB prototypes the easy way.
PCB Way was kind enough to sponsor part 1 of this video series. If you're looking to make your own C64 Saver printed circuit boards or PCBs for any other electronics project you might be working on, please be sure to visit PCBWay.com, where you can order 10 standard PCBs finished in your choice of one of 6 colors for only $5 plus shipping. Okay, break time is over. Let's get back to it.
And where did we leave off? Yes, we've installed 6 of 8 resistors, and I think we have time to quickly install the last 2, R7 and R8. Ta-da, done. All the resistors are now installed, and similar to the resistors, I'm going to install these 2 through-hole zener diodes. Magically, the little zener diodes are now installed, and it is very important to point out that these little diodes are polarized, meaning they have an anode and a cathode side and must be installed in the correct orientation. The PCB silkscreen shows a little line on either side of the footprint, and that indicates the cathode side. When we look at the actual diode itself, we can see that the cathode side is indicated by a black band on one end of the component. So when installing these diodes, be mindful to match the little black band of the component to the line indicated on the silkscreen of the PCB. And with that, things are really taking shape. Next, I'm going to install the transistor at Q1 and then the diode at D1. And then last but not least, we will install the only capacitor. Okay, I'm trying to speed things along here, so I've already inserted the transistor at Q1 and I am soldering the legs. Similar to the through-hole diodes we just spoke about, the transistor at Q1 and the voltage reference diode at D1 have to be installed in the correct orientation. Even though these components perform different functions, they do come in the same package, called a TO92. This component has a flat side and a rounded side, making it very easy to determine the correct orientation. And once again, looking at the silkscreen on the PCB, it is very clear which side of the component is the flat side orientation. Next we install D1. Yes, it's a TO92 package, and yes, I have it in the correct orientation. Oh man, way too much solder. Look at the size of that bridge. Yeesh. Where are you, solder wick? Come on, get in there. That's better. Okay, Q1 and D1 are installed, but I have to say, it's kind of ugly. The transistors for Q1 that I ordered were supposed to have a wider leg pitch to match the footprint of the PCB. However, they didn't. They were straight. I had to bend them out myself, which is fine, although I don't think I did a very good job. And when the component is finally soldered in place, it looks kind of crooked. Anyway, let's keep moving along and install our last component, the capacitor at C1. Again, orientation is important here. Make sure that the white stripe of the capacitor matches up with the solid white area indicated on the silkscreen. Again, blue tack for assistance. Done. I will snip off the legs and we can start testing. I am digging this little guy. I've looked everything over, and as unattractive as some of this work is, it is ready for testing. But before we do that, I would like to take a moment and say that I'm not the first person to build a C64 Saver version 2.4 and post a video about it here on YouTube. Plan C, who also has a retro computer repair and tinkering channel, built this Saver model back in August of 2019, and he chose to install it within a C64 itself. A very interesting implementation. I highly recommend that you watch that video, and be sure to check out all the other videos on Plan C's channel. I will post a link below. And now let's get on with the testing. This is my initial test setup. I have my bench power supply connected to the input side of the PCB. That's here on the right hand side, connected to 5 volts and ground. And on the left side, the output side, I have my bench multimeter measuring the output. My bench power supply settings are all dialed in. I have 5 volts set for the output, and I am limiting current to 250 milliamps because we are just testing at the moment. I will now overlay a shot of my bench multimeter so we can see the output from the C64 Saver. As I turn on the power supply output, we can see that our Saver is now outputting 5 volts as well. That's good, that's what we want to see. I will now increase the voltage 1/10 of a volt at a time, and we will watch to see where our little Saver engages to protect us from an overvoltage. The Saver is still outputting at 5.4 volts, and at 5.5 volts the Saver has engaged and cut the output. I will now roll back the input voltage to 5.4 volts and increase by 1/100th of a volt. And then we can get a more accurate voltage cutoff limit. And we are up to 5.46 volts. And there we go, the Saver has cut the output voltage at 5.47 volts, meaning 5.46 volts is the maximum allowable output voltage. The Saver seems to be functioning well, but some of you might be saying to yourselves, but MindFlareRetro, isn't the Saver letting the voltage get too high before it cuts off? Well, yes and no. According to BWAC, the cutoff voltage needs to be a touch higher from the nominal voltage so not to accidentally trip when there is interference in the PSU output voltage, or there is a voltage spike when the power to the C64 is switched on. Most of the RAM chips used in C64s have an absolute maximum voltage tolerance of between 6 volts and 7 volts depending on the RAM manufacturer. Yes, the recommended operating voltage is 5 volts plus or minus 5%, making the maximum voltage 5.25 volts, and in some cases plus or minus 10% or 5.5 volts max. The power supply article on C64wiki.com, a trusted source as far as I know, has a useful voltage reference chart, and it states, "In most situations where a Commodore 64 got killed by its power supply, the voltage had risen above 6 volts. Usually the RAM memory gets damaged first." So, back to the question, does the C64 Saver let the voltage get too high before it cuts off? The answer is yes, it does allow the power supply voltage to rise to about 5.46 volts, but this is by design. And powering your C64 with an original power supply is a lot safer to do with a Saver than without. So I guess it's about time we gave this little guy a home to live in. But we're going to do that in a third video. Yeah, if I don't break up these videos into more parts, it's just going to be way too long, and I still wouldn't have released the first part yet. So please be patient, bear with me, and hopefully we'll get this all wrapped up in part 3. And yes, you will learn what's up with the potato. But wait, before you go, I want to thank everyone, all my subscribers once again. I appreciate your support very much. And in particular, my Patreon supporters, thank you all very much. You know who you are. And on that note, I have a new Tier 3 High 5 tier supporter. So low level, this high five's for you. And if you happen to be a Patreon supporter of this channel, I have a second cookie cutter to give away. So one of my lucky patrons will be winning a cookie cutter in this giveaway. Thank you for your support. I'll be back with part 3 very soon, and we'll wrap it up really soon.